Happy Friday, everybody. This is the lesson for the 20th, November 2020. And I'll start out with a report on how our first day of virtual hybrid went. Okay. I was very pleased with the attendance of the B-Day kids who had to check in with Google Meets. But man, the A-Day kids, they tuned out. I had a ton of people gone who never bothered to do the attendance question. So you need to make sure you do that. Don't start this, who knows how long this virtual hybrid learning will go. Don't start out by getting behind. You have to make sure you get yourself on time. Here's the schedule again. Please call for help. I'm available all day. So here's my contact information. Here's the schedule. I don't know if they gave you these stickers. These are important so you know what hour you're in and so you can stay caught up. All right. So what we're going to do is some density stuff today. And the shutdown that we just started is kind of rotten timing for us because this is stuff that's way better to do in person. So if you get stuck, I could help you right away. So if you don't get this, it's up to you to let me know so I can help you. Okay? We got to talk about density some more. This is such an important concept. It's not very complicated. Okay? And with a little bit of practice, you'll do fine with it, but you have to do a little bit of practice, okay? It's not like you were born knowing how to calculate density. All right. Density is mass, how much of something there is, divided by how much room it's in, how much room it takes up. And it'll usually be talked, we're going to keep it in metrics because it's so much easier. It's usually going to be in grams. And if you need to know how big a gram is, it's basically a paper clip. That's about a gram's worth of weight. Or a kilogram. If you were in class, I'd pass this around so you could feel it. This is 2.2 pounds, okay? Usually it's grams or kilograms. I'm gonna write G or kilogram, which is 1,000 of them. kg. Okay? And the volume is usually gonna be in milliliters. Which is ml. Or if you're using something bigger, it might be in liters, which is L. I'm going to hit pause for a second here. I think there's a call coming in. All right, I'm back. So, we're going to deal with some smaller examples where we use grams, like this paper clip, and milliliters. Now, if you think this, don't let yourself get fooled and think, oh, this sounds technical, and oh, I won't ever get this. Yes, you will. You're exposed to this stuff all the time. If you ever watch any real or fake medical shows where somebody's being given like a shot of something, like adrenaline or whatever, if you hear a doctor or nurse yell out how many cc's to give a patient, okay? A cc is a cubic centimeter, and it's the same thing as a milliliter. Let me write that down. This is something that's milliliter. aka also known as a cubic centimeter. Now, one of the things I'm good at is being able to explain things in more than one way, okay? And I try to connect it up to stuff your brain already knows, okay? So don't let yourself be worried about this metric stuff because it's meant to be easy to use, okay? Your pinky fingernail is about a centimeter wide, not long. It's about a centimeter wide, okay? I'm just going to draw this. I could freehand draw it. I'm going to cheat and trace it. I very carefully made this one. This is a little cube of solid wood that's 1 centimeter by 1 centimeter by 1 centimeter. Draw that freehand. It's okay. It doesn't have to be perfect. Tell yourself that is 1 cubic centimeter. It's a centimeter by a centimeter by a centimeter. Cubic means multiplied by 3. 1 cubic centimeter. It's 1 by 1 by 1. 1 times 1 times 1 is 1. Okay? Now, if I don't have this, but imagine that I can make a perfect little cube box that was empty on the inside, not solid wood, but a cute little clear plastic box that was exactly 1 centimeter by 1 centimeter by 1 centimeter empty. Okay? Try to visualize how much water that would hold. Okay? I'm going to show you how much water it would hold. See this syringe? It does milliliters. Each one of these marks, see where it says 2, 4, 6, 8, 10, 12? Okay? So the ones that aren't marked are the odd numbers. This thing right here, I've got the syringe stopped at 1 cubic centimeter, 1 milliliter. I'm going to show you how much water that is. Okay, I've got a glass of water here. It's not that much. If you're talking about medicine, it's quite a bit of medicine. Here is, I'm going to empty it back out. Oh, I got air in here. I'm going to get rid of the air too. Okay, I'm going to make a mess. Okay, I'm going to move my camera away from my paper. I'm going to show you how much a cubic centimeter, 1 milliliter of water is. It's that much. Can you see how much that is? I don't know, can we see? That puddle. Okay? That's 1 cc, 1 cubic centimeter of water. 1,000th of a liter. If I made 1,000 of those little messes, that'd be a liter. Okay? Like you've bought pop in 2-liter bottles. Okay? So I'm going to clean that up before I go any further so I don't have a wet mess. All right. I'm going to slide back. Now, I told you, you have experiences in your life already with cubic centimeters and milliliters, not just medical stuff. If you've got a moped or a chainsaw or a gas-powered ice auger for ice fishing, a small gasoline motor is usually sold by the size of its piston. Like I used to have a moped when I was in college, it had a little tiny 50cc motor in it. It would not go very fast. Okay. What else? So, 1 cubic centimeter, you can abbreviate those as cc. Okay. A milliliter is the same thing as a cubic centimeter. Okay. If you remember that, you're going to be fine. Now, let me show you a big cube. Okay. This is 1,000 cubic centimeters, 1,000 cc's, 1,000 milliliters. If this was a clear plastic box, it would hold a liter of water. Okay, look, it's a clear plastic box. This would hold a liter of water. Okay, I'm not going to fill that up and make a huge mess. Okay, that box would, if I crammed it in, I'd break the box. But this wood cube would fit just inside of it, and I'd never get them apart. Okay, that's a liter of water, or right now it's a liter of air. Okay, this is a liter. Okay, 1,000 cubic centimeters. Here's 1 cubic centimeter. Here's 10 cubic centimeters. This bar. Okay. Here is 100 cubic centimeters. I know in elementary school you probably got to play around with little unit blocks that were plastic. Here's 1. Here's 10. Here's 100. And this whole thing's 1,000. All right. Now, that's going to help with density. Okay? Because this is, right now we're doing volume. Okay? All right. Now, scientists are cheaters. They want to make their life as easy as possible. Okay? So, when the metric system was invented, they were doing it to make our lives easier. So, here's what they did. They decided 1 cubic centimeter of water, 1 cc of H2O, that's the same thing as 1 milliliter of water, equals 1 gram. It's so much easier than stuff that you got from the English, pints and quarts and teaspoons, and that's all dumb. Okay, here's a milk from lunch. This is a half pint, or 236 milliliters. Those are not easy numbers to use. Okay, 236. Yeah. Anyway, all right. 1 cc of water is 1 gram. Okay, so this is the volume. This is the mass. Okay, there's the volume, and there's the mass. Guess what? Here's a math problem for you. And by the way, you do want a calculator, either a calculator or a cell phone calculator, or on your Chromebook. Guess what 1 divided by 1 is? 1. The density of water is 1. Okay? The density of pure fresh water equals 1 gram per milliliter, or 1 gram per cubic centimeter. Same thing. 1. What a nice number. Easy to use. All right. How are we doing on time? 14 minutes already. Good grief. All right. Next thing. We're going to watch some YouTube examples. I'm going to show you liquids of different densities. You may have done this before at Southwest. The science guys.
Hey guys, what's up? So I am super into
She's not the science guys.
Generation Genius. And they cover all the science standards for every...
Welcome to the Sci Guys. On today's episode, liquid density.
Hey, I'm Ryan.
I'm Mark.
Welcome to the Sci Guys.
On today's episode, we're going to be talking about the density of liquids.
Hey, what are you calling dense?
The density of a liquid is determined by its mass, or how closely together the molecules of that liquid are packed. For this experiment, the equipment you're going to need is a glass or similar container to build your density tower in,
A bowl to store your liquids in,
a spoon for mixing.
and a turkey baster to gently add your liquids to your tower.
Although we're not dealing with anything hazardous in this episode, it's never a bad idea to wear safety glasses and an apron or lab coat to protect from spills and splashes.
The ingredients you're going to need for this experiment include rubbing alcohol,
Some dish soap,
lamp oil,
baby oil.
and a couple colors of food coloring.
We're also going to need a couple ingredients from the pantry and the fridge.
The ingredients we're going to need from the cupboard are extra virgin olive oil, canola oil or vegetable oil, corn syrup, honey, and chocolate syrup.
This is the worst cooking show ever.
From the fridge, all we'll need is some whole milk and some maple syrup.
Now that we have all our ingredients, we're ready to start. The first step is to take your honey and pour it straight down to the bottom of your cup without hitting the edges of the glass. If the honey touches the side of the glass, it is best to wash your glass out and start over. Honey on the side of the glass can mess with the rest of the layers. Next, fill the turkey baster with corn syrup. The turkey baster will help us to gently add the liquids to our tower without disturbing the layer below it. Now gently squeeze the turkey baster so some of the corn syrup rests on top of the honey layer. After making your syrup layer, wash and dry your turkey baster. You will need to wash and dry the turkey baster after each liquid has been added to your tower. Next, use the turkey baster and slowly add the chocolate syrup into the glass. From this point on, you may need to put your finger over the end of the turkey baster so you can get it low enough to add the layers without disturbing the previous one. Now, add the maple syrup. As you can see from our tower, a little bit of the chocolate coloring from the previous layer mixed with the maple syrup because we added it too quickly. To avoid this, add the maple syrup as gently as possible. Our next liquid to add is the whole milk. Now add the dish soap.
Notice these layers.
Before you add the next
These
layer,
liquids don't want to mix.
mix in a little bit of food coloring. We're using purple.
These
to make it
liquids
stand out
are
from
trying to
the
stay
rest of our
separate
liquid.
from each other.
After the food coloring is mixed in, gently add the water to your tower with the baster. Next, add the vegetable oil to your tower. Then the extra virgin olive oil. Now before you add the rubbing alcohol, mix in a little bit of food coloring. We're using green so it stands out. Then gently add it to your tower with the turkey baster. Now add the baby oil to your tower. The final layer we will add to our tower is the lamp oil. You now have a density tower that has 12 different layers and shows how different liquids can be stacked because of the differences in their density. Let's look at this a little closer. The density of a liquid is determined by how many molecules of a substance fit into a set volume. If you remember from our electrolysis of water video, water has around this many molecules of H2O in every 8-ounce cup. This is because water molecules have a specific size and they like to stay a specific distance away from each other. If an 8-ounce cup of a different liquid has more molecules, or if the molecules are larger, then it will have a higher density than water. And if a liquid has less molecules, or those molecules are smaller, then it will have a lower density than water. A liquid that has larger molecules that are closer together will have more mass or weight than
More
a liquid
atoms.
that has smaller molecules that are spread further apart. This tells us that if a liquid weighs more than another liquid, and they are of equal volumes, then the heavier liquid has a greater density than the lighter liquid. Liquids with higher densities will sink below liquids with lower densities. If we look at our glass, the liquid at the bottom of the glass, which is honey, has the highest density, and the liquid at the top of the glass, which is lamp oil, has the lowest density. There are other forces that are contributing to how these liquids layer, but we will examine these in future episodes.
Well, that's it for liquid density.
Thanks for watching, and remember to subscribe and comment below.
Be sure to like us on Facebook and follow us on Twitter.
And as always, if you have any questions related to science, or if you're having trouble in school,
All right. I don't know if you've ever done that kind of thing before, but that was kind of cool watching the liquids not mix. Okay. Now, that's going to come in important when we're going to talk about inside of the Earth, because you're going to have liquids of different densities that do not want to mix. All right. Okay, I'm already at 20 minutes here, so I'm going to get this wrapped up pretty soon. Okay, so that isn't very much writing for the day. Okay, now density is one way to describe how much matter is packed into a space. How many atoms are in that thing, or in that amount of something? Okay. Liquids of different densities. We're almost done. You can abbreviate DIF. Liquids of different densities will separate. More dense toward the bottom. More dense goes down, less dense goes up. In real life matters, like if there's been an oil spill, why do the animals, especially the birds, get coated in oil? Because the oil is on top of the water. Okay, most of it was. Okay, sometimes the tar will go to the bottom, but the animals and birds that were up at the top of the water will get coated in oil. Okay, oil is less dense and will float on the water. Let me see. Was there anything else there I want to know? I'm just going to write that down for an example, then we'll quit. Oil slicks, oil spills. Less dense oil will float on top of water. Problem for birds and animals. Don't Google it. I mean, if you want to get depressed, look at animals in oil spills. Cute little sea otters having to get rescued and cleaned off before they die. Anyway, we're going to call that quits for now. That's 23 minutes. I'm going to hit stop. And let me know if you have troubles with anything. I think this is pretty easy stuff so far. We're going to do some math problems with this next week. Remember your class schedule, and Monday will be an A day, so A day kids will have to check in with their teachers each class period, the beginning of the class, first 5 minutes in their Google Meets. Here's your schedule again. See ya.